Welcome. I'm Alexander Rose. I'm the executive director here at the Long Now Foundation, and I'm joining you live from the unfortunately closed interval. For this one, we actually filmed it here at the interval, but it was great to work with a small socially distanced crew to be filming here. And I hope that the recording kind of gives it a different feel than something that was just being recorded in one of our living rooms. So we brought you a few scenes of that recording. And like the last talk, we actually recorded this a few weeks ago to give us a chance to edit it all together. But Brian, our speaker tonight, will be joining us for a live Q&A, as well as Kevin Kelly from our board. Tonight's speaker is Brian Fisher. He's an entomologist who's been working for many decades in the field and specializes in ants and has identified over 1,000 ant species and is one of the greatest storytellers I know and adventurers that I know, and I've always loved his stories. He specifically has been working in Madagascar for over 30 years, where he's gotten to know the local community and realized that the challenges they have facing them in bringing protein both to their diets as well as for selling have also challenged the environment. And tonight he's going to be talking about really where his work in entomology and this need for protein come together in Madagascar. Welcome, Brian.
Thank you, Xander. It's great to be here at the interval. I first want to start with the love of ants. I must admit, I never knew I was going to study ants. In fact, my kind of gateway into all this world was simply wanting to be outside. As a kid, I wanted to be outside. I knew I had to be outside for the rest of my life. And I thought, oh, I want to be an explorer and be a scientist and study botany, in fact. In fact, plants was what I wanted to study. And when I went to the tropics, all I saw was ants. And I was like, who studies these? They should study these. And people said not too many people know anything about ants. So I switched right then, dropped the P and the L and stuck with ants until now. Now, for most of you, ants and all insects are invisible. But actually, they're the glue that holds systems together. They're the glue that hold forests together. Without insects, we can't talk about preserving forest. But it's those insects that brought me to Madagascar. Now, when you say Madagascar, what do you think of? It's on your bucket list for a vacation. It's that unique place to go and discover the wildlife, the beauty. Now, behind Madagascar is an incredible story of geographic isolation, incredible biodiversity, but just opposed to all that, 50% of the children are malnourished. It's one of the few countries that has an increasing area of poverty, where 90% of the people earn less than $2 a day. And at the same time, you have 10% of the natural habitat left. That means the current system that's handling population growth is going to break. You can't put more cattle on degraded land. You can't cut down more forest to grow corn if there's no more forest. But why I went to Madagascar is the same reason you would want to go to Madagascar, and that is for the wildlife. I went there to discover the insects. And to me, it has been the best, incredible dream for the last 25 years, exploring all over Madagascar. Now, when you think expedition adventure, maybe this is what you think of. You're just floating down this beautiful jungle, and off to your right and left are just new species to discover. But in Madagascar, it's much more challenging. In fact, we spend most of our time just getting to the forest. And for me, that's really been how I got to know Madagascar. You know, I would use Google Earth maps to find that remote forest and then find out how to get there. But to get there required enormous cooperation from everybody. We would only do our work in the rainy season, which meant working and driving and getting places that we're not supposed to be able to get to in the rainy season. But we would take our trusty Land Cruiser and off we'd go. And it required village after village after village of people to help us. And working with those people and finally getting into the forest was how I began to fall in love with Madagascar. And this was an incredible privilege to go into these forests, be the first one there, and in your backyard, you have all these incredible insects to discover. And at the same time, you're training people that have never been to this forest, this incredible world of insects. Now, my specialty is ants. And believe me, we have made great discoveries. We have discovered over 1,000 new species of ants in Madagascar, like this one shown here, the hero ant, a new genus only found in Madagascar, in which these ants, to protect their home from an invader, when the invader comes and gets on that lip of clay, it jumps off, it grabs them and jumps off, and keeping that predator away from their nest, which is only found on clay banks. We also established traps all across Madagascar. In fact, right now we have 50 what's called a Malays trap, which catches flying insects so that we can monitor them. Why? It's because we want to create a system like a Dow Jones indexed environment in which we can monitor in real time our impact and changes that are happening. The index will give us a glimpse of what's happening to this glue, the insects that are holding forests together. We need to understand our impact on forest, and we can do that by looking at the insects. Now, you may have heard about this incredible decline of insects, the insect apocalypse. Well, we don't even know if that's really happening because we don't have the monitoring systems in place. But a system like this allows us to actually learn something. But with insects, you got to be ready. There's a lot of them, and our traps catch a lot of insects. That meant we had to train an enormous group of people. And thanks to the generosity of the Bay Area and the California Academy of Sciences, we've built a beautiful center of research that includes a dedicated staff for the study of insects. And it's with this team we've explored over 400 places across Madagascar for insects. And over those years, I've gone back to beautiful sites and been confronted with this. And it made me wonder what I was doing to help save the forest. And I began to wonder if in 50 years, are we going to have any forest left in Madagascar? And without forest, what does that mean for all the people I've worked with, all the people I've gotten to know and care about? Population has doubled since the time I started working in Madagascar. What does that mean for the future? Now, that's a problem that the world has to come to terms with. It's not just for Madagascar, but we have extended ourselves well beyond our normal means for using landscapes. So I began to think, I need a change as an entomologist. There's a role I can play, and it has to happen quick. And I began to think about the people and the landscapes, and I realized I have to stop working just in those pristine little dots and begin to work with the people that live around those forests. And it comes down to how are they going to feed their kids if they can't access the forest? If they can't cut down the trees to grow new crops, if they can't hunt for bushmeat and kill the lemurs, how are they going to feed their kids? They're running out of options. There's already migration where people are moving and looking for new possibilities, and there are none. That meant coming up with a new solution, and I call that the breakfast before conservation. Now, as an entomologist, at first I thought I had no role to play in this, but then I just started looking around. I was kind of blind to this, but do you see it? Those are insects there. In Madagascar, they eat edible insects. Now, insects, you may have heard about this now, that more and more people are turning to insects for lots of reasons. In fact, it just makes sense. Insects, unlike warm-blooded animals like a cow or a pig, you don't have to waste energy on heating the body. You don't have to give it extra water so it can sweat. Looking at it in terms of gains for insects, compare it to cattle, where it takes like 2,000 gallons of water to get a pound of protein, compared to only like 50 gallons for a cricket protein. Also in terms of space and impact on CO2. It takes 6 times the feed to get a pound from a cow compared to a cricket, for example. So that simple conversion rate, even if you're feeding it the same thing, you'll get 6 times the protein if you're feeding it to an insect compared to cattle. In fact, studies have shown that you can absorb more micronutrients from eating insects than a slab of steak. So you have efficient conversion rates, you have more micronutrients, and more studies are now showing that it improves our microbiome if you eat insects. So it just makes sense. So I wanted to see if there was potential of building on that tradition in Madagascar and finding maybe potential native species in which we could actually farm. So to begin that, going through the history of the last 400 years and reading about what people ate before and digging up recipes and documenting it. And there's some really interesting discoveries there. In fact, the first insect mentioned in 1658 was this cicada called a flathead. In fact, they didn't even know it was a cicada. Like, they called it a butterfly, and then they called it an ant. But actually, this insect, the red ones there that look like flowers, they tap into phloem and actually exude a bunch of sugar because they have to look for micronutrients in the phloem inside the plant. So they create these fist-sized piles of sugar that the locals would gather up and eat. So would the lemurs, too. But this was highly sought after. In fact, during the colonial period, a French botanist actually tried to farm these and create this manna, he called, in Madagascar, using this incredible flathead. But the real star of this group of insects is what's called the secundri, the one with the strange kind of harness on its head there. Now, these are amazing, and this was the other most talked about insect in this group in the literature because everybody loved to eat it. It tastes like bacon. The locals call it secundri, but in English, you can call it the bacon bug. Like bacon, you can just put it in a pot and fry it up in its own grease, and it's delicious. Going back and reading through the history, we also discovered that one group of insects was the most easily absorbed in other types of cuisines, and that was the pupa from silk moth. French chefs in Madagascar would actually serve it in the French residence in 1884, and they would describe it as some butterfly brains, because it tasted like veal brains. And even the last queen of Madagascar used to have special helpers that would scour the countryside for these types of edible insects, including the silk moth pupa and also locust. And to my surprise, I didn't even see this before, just next to our center in the capital of Madagascar, they sell pupa of silk moths. And do note that they are selling it next to shrimp, which is actually also a crustacean. So it's actually phylogenetically the correct place to sell it in the market. And it's actually sold at the same price as shrimp. In other words, historically, they valued edible insects. They're sold at a very high price, and there's a long tradition of it. But one insect is actually more like a staple, and that is the locust. Now, when you see a locust swarm or hear about it, you may already be so biased that you think, oh my God, this is terrible. Which to me as an entomologist, I want to question that behavior, because when we look at like a South Sea island full of penguins, or in the Serengeti, a wildebeest migration, we think of something actually, wow, the abundance of nature. But the abundance of nature when it comes to insects actually should be looked at in a different way too. Now, the locust has been recorded as something that supersedes everything if a swarm comes. In fact, an early explorer documented when there was a war going on that after 10 days of battle, a locust swarm arrived, and all the soldiers stopped to gather up the locust. All the villages which were hiding from the war came out, and everybody, 20,000 of them, were gathering up the locust. They went to the king and said, what's going on? They said, well, because usually a war only interests those who started it, while locust interests everybody. So they gathered it up because it's an important element of food security. And the recipes that we documented in the literature are the same today, where you would gather up a locust, take off its wings, stick it in a pot, and when it turns red, like a shrimp, it's ready to eat. Or you can actually boil it, put it in the sun to dry it, grind it into a powder because it's more stable, more compact, and they can travel with it, and it becomes a staple for the rest of the year when they may not have rice or corn to eat. Locust is like a staple. You know, any forward-looking homekeeper keeps locust in their house because they need that when there's times of lean. And it's a safeguard. And that's why it's become a staple. Early explorers said, wow, Madagascar is a place without famine. They can always eat the locust. Now that's changed a lot. There is a lot of famine. I wondered what we could do. I wonder if we could actually use this knowledge about edible insects to come up with a very simple solution, in a sense, that blends with their tradition to solve this important problem of malnutrition, which is directly related to deforestation and bushmeat consumption in Madagascar. So we began some tests. So our results show that in Madagascar, for example, 70% of people consume insects. And that means still there's 30% who don't. They could, in their family, decided it's what's called a taboo. It's called a fadi. So in their family, they don't eat insects. Or it could be that the whole village doesn't do it. So there are many reasons why people don't. But It's also interesting why the 70% do. And when do they do it? More and more, we're finding that almost all children consume insects, but it's a very hard thing to find out. When you go into a house and they're doing the inventories about food consumption, they'll say, basically, what are you eating? And the kids aren't there. The parents are saying, we're feeding them this, we're feeding them this, and there's no insects. But if you talk to the kids, did you eat insects? They say no. And then you watch them and they're just snacking on grasshoppers on the way to school. You're like, hey, wait a minute. You just said you don't eat insects. Oh yeah, my mom doesn't give me insects, but I eat them all day long. And we think actually there might be an important element being missing in the diets, and maybe that's the only protein they're getting. Because when meat comes into the family, when bushmeat comes in, it's actually almost always eaten by the men. So the women and children are not getting the protein. How are they living? And this could be one avenue in which they're getting that protein. And that also means that if we give them secundary, the bacon bug, or other insects, the kids will get it. And our results show that. That actually is distributed to the people we want to get to. Because if children aren't eating, when they go to school, they're not learning. So if we want the next game changers to come out of Madagascar, we want to give them hope. And the only way to do that is to actually have smart Malagasy. And you got to feed them. And I think insects is one way to do it. So we began to scour our knowledge base of all the edible insects we inventoried in Madagascar. And we realized the best solution would be something like the locust that we could actually grow, grind into a powder that's stable for maybe up to 2 years, and ship it across Madagascar. And that's when we reached out to Darren, the cricket guy. Darren and his brothers, Darren Golden, is in charge of the largest producer of cricket powder in North America. And he agreed to help us once we found a candidate species to help us develop a process to actually grow at a more efficient and effective rate crickets in Madagascar. But we needed to find the cricket. So we turned to Sylvain, a cricket expert in the region, and we went out and inventoried and started rearing different species of native crickets to figure out which one was okay to crowd together, which one that we could actually feed something like grain. And we actually found a beautiful species called Gryllus madagascarensis. And so we had to actually test, working with the teams at Intimo Farms and Sylvain and our local staff, and train them and develop, and we figured out a protocol. Now, it's a 6 to 7 week time span in which it goes from egg to actually adult. And unlike all other kind of farm processes, we're harvesting the cricket just at the end of their life. Just when they finish laying eggs, just before they would die naturally, we would harvest them. We grind them up to make it more efficient in the drying process in the ovens. And once they're dry, we blend them into a powder. Now we have a powder. So our research and others have shown that 25 grams of cricket powder is sufficient for a daily dosage. And for me, every morning I take a spoonful of cricket powder and add it to my yogurt. It's like stracciatella. It actually has a chocolate taste, and it's actually fabulous combination. And that's how I eat it. But in Madagascar, it's usually added into a sauce that's added to the rice. It's a very sauce-based culture, and it's easy to add that in. In fact, at certain times of the year, that's all they have. So they just add the cricket powder to water, and that's what's eaten. We've recorded over 100 insect species that are eaten in Madagascar. But they're not eaten all the time because they're only eaten when they're present. And that could be just for a week or a month. And what we want to do is actually find the best candidates for farming and then find a way we can farm them all year round. And that's where the innovation comes in. How can we break the system so that they can keep cycling and be abundant all year? So we are currently having our pilot farm, we call it, that produces 30 kilos of product a month. And we want to change that to be enormous because it's scalable. But at the same time, it's a quick response. So for example, if you got hungry and then bought a baby cow, you have to wait a long time before you can eat it. But here, if you just get some eggs, within 6 weeks, you can be eating the product. So you have a very short response time. And the equipment required to get going is very limited because they don't require much water and much feed for the conversion. So what are we going to do in Madagascar? We want to actually sell this product to different groups like famine relief agencies. But to do that, We had to get the first certification in Madagascar to actually sell an edible insect product. We were lucky working with the Minister of Health. We were able to get a permit. We named our farm Valhalla Farm, showing the Queen's Palace there, which is just above our farm. And we also got our process certified by an agency called Entotrust, which is an international organization that means that our standards, our health standards and our sustainability standards, are complete. So we spent the last 2 years learning how to grow with less space, more efficient, get more product for that effort. And we started producing on average about 30 kilos of product a month. Now we have this beautiful product, and we had to find, buyers. The idea is if we could sell this, we'd impact people, but also be able to use this funds to continue our research and to expand our village programs. Imagine if we could actually link large-scale farming with our efforts in the village. While working with Catholic Relief Services, we started using our product in famine relief. It was a complement to the diets, to the meals, the food packages given to the 55,000 families in the south of Madagascar. They wanted a lot of product. We couldn't provide them a lot of product because at the same time, we started getting other demands. And really an interesting case was a tuberculosis clinic in the south heard about it. They also wanted our product. And they said, but we'll do an experiment. We'll give it to half the people 3 times a week. And it just started working. Half the people, for the first time, started to gain weight. And they started to have an effect from the medicine. They started to get better. In these types of environments, there's actually no response for taking the medication against TB because you're so already deprived. But they started getting better. So much better that the other half of the people noticed. And they said, wait a minute, we also want the powder. And there was a strike, and they refused to accept another meal until they also got the cricket powder 3 days a week. And then they said, no, we want it 5 days a week. And this was such a success that now they want to expand it to 10 clinics across Madagascar. We don't have enough product for that because we also launched a program to feed school children in the capital, in the poorest areas. But it also has an impact on the people we work with. We're providing jobs. In fact, we've made sure that the whole process is really managed and run by the Malagasy staff, and that means training. Like myself, I didn't know how to farm a cricket or a bacon bug. We went also and worked with the best chefs in Madagascar to come up with traditional recipes to integrate our product into food. And we're learning together, and it's really their innovation, their problem solving on a daily basis that's making us a success. Now, we were worried about maybe in the urban sector, we would have a different perception, but the children had no problem. But I also want you to note that we also get something else. We get equal amount in weight fertilizer. You say, what, fertilizer? Well, crickets do poop, and that poop, called frass, is a fantastic fertilizer. We initially thought our project would only impact malnutrition and bushmeat consumption. I didn't really appreciate that we'd also produce an equal quantity of fertilizer. And this fertilizer is not ordinary fertilizer. It's like magic stuff. And elsewhere in the world, it's already being sold. For example, the marijuana industry loves this stuff. And that keyed us into maybe there's something special about it. So we started using it in reforestation projects, and it's had a huge success. Reforestation is a really difficult subject. It almost never works in Madagascar. We need all the help to actually restore even the tiniest amount. But somehow the cricket frass is actually restoring the soil, and that's been key, I think, to why we're having such success. But it's something also that as we expand and create more and more farms, we can link reforestation or improving the degraded landscapes around these communities so that they have more water, they have more resources. It's a more holistic approach to malnutrition. We improve landscapes, we improve their health, and it's that togetherness that actually makes it work. So now we are hoping that we can actually participate in the 60 million tree plantation project that's happening in Madagascar, and here are some early results that are super successful. But imagine if we could go into a village and we could give them crickets and also something for their local garden. So we've been designing small little portable units that we could actually bring into a town, just a house, just a community, and when they could farm a small amount and then use that manure for fertilizer for their own garden. Well, we've shown now that it's possible. We've shown that we can actually find native species, learn to farm them, people like them, people benefit from it. We have to scale this up to meet the problem. So we wanted to actually create a much larger farm and actually expand our research to find more insects we could farm in different areas of Madagascar. So we got the okay from the Minister of Education. They provided land for us, actually near our existing center. We've designed it, and now we're actually fundraising to build our first large-scale edible insect center in Madagascar. And that's really part of our plan, imagining going across Madagascar, linking large kind of urban farming with local village projects where we address the issues in those villages through edible insects. Maybe it's malnutrition. Maybe it's against bushmeat consumption. Maybe it's soil erosion. All this can be addressed through edible insects. It can be small, just one house. It could be huge, a 30,000 square foot farm. Maybe you feel a bit squeamish about eating insects, but I want to tell you at the same time, it's a booming industry. In fact, you might have seen some of these products. Well, Intima Farms is the largest, but there's others, that Quick Start that makes a great bar. There's Chip Chips that makes great cookie dough and chips. But what this shows us is that people are willing to try, even in North America, to eat this. And it's actually an industry that will continue to increase as we run out of other options for increasing production of food. And over and over again, I'll say this, because it tastes good. And that's why you'll be eating it soon. Now, this solution, though, is also exciting because it involves an incredible amount of science. This has been some of the best and most exciting science I've done. And I find out the next day if we failed. And this, to me, makes me excited to be a scientist and actually be able to work on such an important project. But you may think, well, that's nice. What does it concern me? You may be thinking, well, things get really bad here. Aren't we going to Mars? Isn't that the solution? Well, we already know what you're going to eat on Mars, right? Potatoes. We've all seen the movie or the book. But you can't live off potatoes. And we know there's nothing to waste on Mars. So the only solution for food there will be insects. It's the most efficient choice. So why wait to Mars when you should be starting this now? This pandemic we have right now has forced us to rethink how we live. Everything about our daily lives has changed. This is the time to make other personal choices about how we want to come out of this. Are we going to come out of this just the same? Or are we going to realize that actually we can't be against Mother Nature? We have to be part of this. We can't fight the system by always taking more and more of Earth. We have to find a way to actually be part of the system. And insects offer us a much safer avenue of going forward if we want our society to be anything similar to what we have now. This is a great choice. And I hope that you can think through, and if you're interested in participating in this project, we're still looking for exciting people to help us carry this forward. And I look forward to hearing your questions. Thank you.
Thank you. I want to get this started. I think, Brian, you mentioned in a few places where the Malagasy government have been helping you, but I just wanted to get a sense of kind of the larger kind of acceptance of this program and how they're working with you on this or not.
It's great to be part of a project that has momentum, and we don't even have to tell people about this project in Madagascar. They come to us, and for somebody who's worked on insects before, that's striking. We have been invisible ourselves for 30 years in Madagascar, but now it's getting noticed because I think people see it as we were told over and over again, it's a no-brain solution, and it's something they want to support. And often I think it's because they remember that they too ate insects. So it was the first time we had to actually introduce this as a permitting process for the Ministry of Health. But they were like, oh yeah, I eat insects, so it must be good, but let's go through the process and learn how to do this together. They were open to it, and that's what's been so exciting. And there's so many people involved from so many different sectors that it's an incredible synergy that's taken this project forward.
That's really great to hear. And I know that I think you made a trip there right as the quarantine was kind of going into effect, and I think got home just on some of the last planes. How was the pandemic affecting them, and have you heard since being there?
Well, it has impacted a few people. They got sick in Madagascar, but as a whole, they've been one of the lucky countries. The countries where there hasn't been a huge impact. It's been locked down, so they've been very safe. But in the beginning, it was quite a shock to hear, while we were there in a very small village, that the country was closing and that there was a flight. It was difficult because we were stuck in a cyclone for 5 days with about 1 meter of rain coming down and high winds. And to be honest, that was more of a concern than thinking about trying to leave the country, but we made a dash, and luckily we got on the last flight out of the country. I didn't get very far. I got to Paris only, but I did get out of the country.
Nice. We have a question from one of the live streams from Brad Perkins. What are the crickets being fed when they're in these commercial farming environments, or what are all these bugs being fed?
Oh, that's a great question. In fact, each insect that we look at as a potential farming insect, we have to actually really understand what they could eat. So the secundry, for example, that eats the phloem of a plant. So you don't feed it feed or grain, you actually give it a plant to grow on. And here we're using a bean that the secundry live off of, but then when the bean becomes mature, people can harvest the actual beans from it. And almost any bean will work. But now the cricket, in nature, it eats detritus or anything that's decomposing. Now, in the farm environment, we had to standardize it. And we first chose to standardize it on spent millet because it's cheap and it's in abundance if you're next to a brewery. It's the waste from a brewery. So we would, order a ton of it at a time, and they would have it dumped off, and it'd be this pile of smelly millet, and we would feed it. But as soon as we started looking at experimentation to improve yield, experimentation to monitor the impacts on nutrition, we had to standardize our feed. So we have a simple grain-based feed right now, and the mixture is changing, but it's a part corn, bean, sorghum, but it's wide open. And it's, to me, the biggest area of future research. Because when you bring a mini farm to a person, a village, or a farm, you have to actually have already figured out how you're going to feed them. So that could mean actually farming plants too to go along with it. So it's in certain areas you have to think of the whole picture. What you're going to feed them? Do they have any vegetable waste? Most often not. So you're going to have to actually either be feeding them chicken feed or actually growing plants to feed the crickets.
Nice. Well, I think the obvious elephant in the room is the ew factor of insects, and I think one of the points that you speak about is really we're eating prawns, we're eating lobsters, we're eating all these bugs from the sea, and they're actually some of our greatest delicacies in many cases, and we somehow don't have the same response to that we do, I think, in Western culture, at least, to eating crickets. I just wonder if you could expand on that. And I know that you found that so much of the world population is eating insects, and possibly vastly more than even is being reported. So if you can talk a little bit more about how those two things come together.
Right. So how to develop good habits of eating insects? Well, I would suggest start off as a snack food. It's actually really tasty to eat that. And if they're already dead and in a spicy maybe or vanilla or something kind of sauce with it, it's actually, you'll love it just as much as you like snacking on Doritos. It's if that's your thing. It's actually quite delicious. And I think that the hard part is just to try it. Now, maybe it'll be easier if we just change the name. We don't call them insects anymore. We call them land shrimp. And and then that will help you get over it. But we don't actually have the culture of eating insects here, but we actually do have a culture of trying something new. So I think just being willing to try it once opens you up to it. And in Madagascar, I'm always surprised that, when we introduce it, there is our worry, well, are they going to eat it? But that's never been an issue. Like when you present it to all 400 kids at the school, the teachers are like, I don't know about this, but no kid says that. they're in it.
It's a learned ew.
Yeah, it's a learned ew. Because they still, every kid when they're, below the age of 13 have eaten it. But I love the secundry. It's a delicious bacony taste. And, if that's, I'm a type of person who loves to snack when I write or work. So I'd prefer to eat secundry than popcorn.
Right. Well, yeah, the idea of a bacon bug is definitely, converting me on that in a huge way. And I remember just being in Oaxaca, it wasn't until several days in that I realized that the salt that I was having with all of the mezcal is cricket-based, this amazing cricket-based salt. And I was like, all right, well, I guess I'm eating insects. And it changed, really the form factor of powder and the change, where it doesn't have legs and all that. And once you've done it, you realize it's delicious and it's, it's as good as prawns, really. So we have, after this next question, we're going to bring in one of our founding board members, Kevin Kelly, to ask a few questions. But I thought there's a great question from Joe off of one of our feeds. And he's asking, is it possible to do this at home? How complicated is the process of producing the powder? What are the resources for this? Can we have an insect farm next to our home garden? If you can talk more about that.
You could absolutely have a cricket farm in your house. You could just buy a large clear container, a big tote, and put in some egg cartons and go out and collect some cricket eggs or buy some online and start. Now you just have to think about giving it a little bit of water and giving it feed. And you can buy chicken feed easily online here. And to harvest them, you can actually freeze them to kill them. You can then put them in the oven to dry them, and then you can grind them in your coffee grinder or your food grinder. It's actually quite easy. And that is actually why it's a useful solution. The technology and the simplicity allows it to scale. The simplicity of it also allows you to bring it almost to any community. When you walk away, you have to make sure they're still going to carry on and use it. It has to be that simple. And it has to be viewed also as part of their tradition. It's not part of our tradition, but in Madagascar, it is part of their tradition, like it is in Mexico. In Mexico, they eat over 500 species of insects. We've documented only over 100 or so in Madagascar, but it's a really important part of their culture even today.
Yeah, well, it's a lot less terrifying than trying to raise and butcher and slaughter a pig or something like that in your home garden. I think that's it's a much more reasonable thing to be doing home protein creation with bugs than doing it with large animals.
And why? Because you go on vacation. When you go on vacation, you can just harvest them all before you leave, eat them.
Right.
Start over.
No, anybody I know who has animals, like going on vacation is actually the most difficult thing that they could possibly imagine. Yeah, that's a great point. Yeah. Okay. So we're going to bring in Kevin Kelly, who's been filtering some of your questions to me, and he has a few questions of his own. Welcome, Kevin.
Yes, I'm wondering what you have learned from the experience in Mexico, because as you noted, there is a very long tradition of eating insects in Mexico, and they may have maybe modernized it or evolved it. And was there anything that you learned about how Mexico does insect eating?
Well, they have helped a lot in diversifying the recipes, the potential of it, and that's really important. It's really some really sophisticated cuisine level aspects of it, which can be borrowed and reused in many ways. But there isn't an exact translation for Madagascar. In Madagascar, we wanted to make sure people there thought of it as their traditions that were augmenting and expanding. So we wanted to make sure we're using the native species in Madagascar. It would have been a lot simpler to go and take a species they've already farmed in Mexico, bring it to Madagascar, and farm it there. But then it wouldn't be Malagasy. And also, we'd be introducing a species. We wanted to make sure we had a native species. So that's where the research came in. And it's been fun, actually, to learn about all these different insects and their taste differences. And that's also exciting. You know, we've researched chickens for 80 years about how to grow them and so forth. And here we are, we're bringing new food groups, you know, food animals into cultivation. And that's really exciting. And it's diversifying the food systems. Also in Mexico, they already, in a sense, had partitioned insects into their diets at a certain level, traditionally. And it really hasn't changed much. And what we wanted to do in Madagascar is actually fill an enormous gap in their society. Don't forget, there's a big difference in terms of malnutrition and poverty between Mexico and Madagascar. So I think the need for this solution is greatest in places like Madagascar, and because it combines their tradition and their solution in one area.
So we've done breeding in the past for food animals and have greatly increased their efficiency and even taste through breeding. So is there any kind of programs to breed either new varieties of insects or new forms of insects or even GMIs, genetically modified insects, that were actually engineered just for food?
In terms of insects, yes, I think every farm is actually modifying their genetics, right? We're selecting insects that meet our criteria, that we harvest them in 7 weeks, that they're laying eggs at a certain time. So we're actually selecting. But our initial stock just 2 years ago was collected in the wild around the capital city. But this species was never farmed before, so it's actually a new species. But there is a giant industry, which is kind of different, for producing edible insects for mass consumption. And that's like, for example, Entimo farms. And there's more and more of them around the world now. And they use a very limited set of species that they're farming. It could be the mealworm or the one cricket that most of these other farmers are using. And they also are not spending as much time on the genetics part, but they're the technique side. Most of the gains are in the efficiencies of managing the actual farming process. I think in maybe 5 years, they'll start selecting special strains to go forward. But right now, there's so much efficiency gains just on simple changing parameters of how you feed them, what temperature, what humidity, and what feed. So those are the gains right now.
And you mentioned that insects are particularly efficient food converters because they're eating plants, farm-raised plants, and converting it into protein. And so animals do that, fish, seafood do it, and insects do it too. Why are insects so much more efficient?
They're more efficient because they're not wasting it on heating the body. All the cows, the pigs, the chickens, the vertebrates, they're spending a lot of energy on keeping their body warm. So when you give them food, they have to spend a lot of it on keeping their body warm and keeping their body cool. And that requires a lot more water. So it takes a lot more water and, for a cow, 6 times as much food to generate the same amount of protein. And now that's just protein. And the insects, because we eat the whole thing, it's more efficient because we're not plucking all the feathers out, we're not throwing away the bones, we're actually eating the entire insect at the end of its life, which is an advantage ethically.
So I'll take a couple of questions from some of the other people online. Rachel Kusik, I think that's how you pronounce it, says, what do you need to scale this across Madagascar? What's the gating hurdle that you need? Is it investment money? Is it adoption? What is the biggest hurdle right now to scale this up into terms of what you can imagine it?
Well, I think this is the exciting part of it, that we have learned how to scale. Our pilot project has showed us that we know how to farm the crickets. We know we can feed them. We know how to do it at any scale. And I think what we're trying to do right now is create our first center of research and farm, our first large-scale farm, to help us address, in particular, bushmeat consumption and famine in Madagascar, malnutrition. So we've set down this path of building out this farm, and we're fundraising for it now. In fact, it's only through supporters and donors have we've gotten this far, and we hope that we can actually raise the necessary capital to actually build it. In fact, our construction plans are out to tender right now, but we still have to fundraise a lot, about $750,000 actually, to finish the building.
Okay. This is Stuart Brand, who's watching online, has a question. Could insects be an intermediate way of increasing the yield of chickens? Chickens love to eat insects. So could you take feed, make insects, and then feed those to chickens? Would that improve the yield of chicken, or would it yield the environmental or diminish the environmental impact any by having that intermediate of feed to insects to chickens?
There are many people that love to raise chickens or see that as a solution for a lot of problems. And it's true that there are some advantages. People already eat chickens, and you can actually sell their eggs. And we've seen data that suggests that if you actually feed cricket powder or crickets, whole crickets, to chickens, they can even double their egg-laying production. So the chickens are doing better. But you still have to feed the crickets, just like you would have to feed the chickens. And whether or not you think it's better to have that product go to a human versus a chicken is a question. I do see that there is an existing chicken industry. So if you just look at that and say, how can we help that industry? I agree. I think there are gains to be made in terms of the impact of the current chicken industry if you actually use cricket food instead of seafood, for example, to feed the chickens.
So here's another online question from Nicholas Brusewicz, and it's, do edible insects get or spread disease the way that livestock does? Is this another reason to adopt insects, because perhaps they don't transmit zoologically powerful diseases?
That is an excellent question. There are no known diseases that could be transmitted by eating a dead cooked insect, unlike we know they exist for cows, for example, mad cow disease, for example. In addition, there's another incredible advantage, is that if you actually cook a steak, you can't keep it in the cupboard for 2 years and bring it out when you have a moment of hunger. But you can do that to ground cricket powder, for example. Once it's dried, it's stable. You can easily transport it around, and you can store it as a ration to be available when you actually need it. And that's a huge advantage. It doesn't go bad.
Okay. I have a question. Your totem animal is an ant. So are ants good eating as well? Do they taste good? And do they make any sense to try and eat ants?
Well, Hymenoptera, where ants, bees, and wasps belong, you often don't eat the adult. The larvae, though, are quite tasty. In Mexico, escamoli is the larva, the babies of ants. And so, yes, you can eat the larva, but you have to get a lot of it. You have to find it, dig up a nest or find access to it. They're really hard to farm, so I don't suggest farming them. In Madagascar, I was surprised to learn that they actually harvest a lot of wasp larvae. And the fact they've started exporting it. A few years ago, they exported 9 tons to Reunion of wasp larvae. You've heard about this great murderous wasp that's going to invade North America. Just think of the larvae we could get out of it. Maybe it could be interesting to farm the big murderous wasp.
That's always the solution for invasive species, is just turn them into food, and then people will eliminate them very quickly. several questions. One from Rone about whether insects would, how that compares to a vegan diet in terms of its environmental impact. And whereas it's like, are insects close enough to plants in terms of their footprint, their carbon footprint in terms of the whole system, or does the fact that you're still farming feed not really diminish that very much?
In terms of an animal, insects are the most sustainable food source there is, without a doubt. Of course, if you just eat plants, that's even better. But this is the best solution for animal protein, is eating insects. And as I mentioned before, it's not eating the chicken in its prime, in its youth, or a cow. It's actually harvesting the crickets at the end of their lives. So we actually have timed it such that we want to harvest just before they would die naturally. About 2 days before they would die, we would harvest them. So it's at the end of their life. And I think that's also very important when you think about what we're eating.
I remember a time when fish farming was seen as a solution. And of course, now the scale that fish farming is done, particularly in Asia, it's become a problem. What kind of problems would there be in farming insects if this was really successful?
Well, there's two angles I can answer that question. One would be in Madagascar. Right now, because we're operating as an NGO and not as a business per se, we can direct all the impacts to the people and the forest. That means we can choose our local villages where we work, where we can impact bushmeat consumption. We can choose where our impacts are going in terms of the price points that we can actually address famine and malnutrition. However, when it becomes a business, it would simply be, we just want to actually grow crickets in Madagascar to export for the world market. And that's when I think it becomes only interesting in terms of a business model rather than the impact for the people. So the advantage of right now the situation in Madagascar, if we are able to expand now, we can actually impact people and, in a sense, democratize the access for protein. At the international investment right now in edible insects, it's great to have all corners of where we can have impact in the world expand, and I think investment is required for that. But we want to make sure, no matter what happens in Madagascar, as we expand, we can actually ensure that the impacts are staying for the Malagasy people.
So what can individuals in the U.S. do to support this exciting adventure into a new kind of farming, a new kind of food source? I could imagine culinary adventures. I could imagine farming experiments. What would you suggest people do to further this initiative?
This initiative is exciting in a sense that it impacts at so many different angles. If you're interested in lemurs, you could be interested in the bushmeat impacts. If you're interested in children, you could be interested in their actual impacts. If you're in nutrition or health-related fields, you could look at the impacts on actual growth and nutrition. If you're interested in reforestation, you could be looking at how and why cricket frass is so effective at improving growth in plants, and not just for the first year, but there's a residual that impacts year after year. Why is that? There are so many exciting questions to look at, and also in terms of just the analysis of the models of this idea of feeding crickets to chickens. Is it worth it? What do we gain from that versus choosing another choice? What are the issues of scaling this model such that we've created such an interest in it that we can't even actually feed the people in Madagascar anymore because the markets are driving us to sell outside of Madagascar. So I think there's plenty of room for diverse backgrounds to go into this. Or you could say, hey, we want to actually make the most efficient building in Madagascar for cricket farming. Help us design it. There's many avenues to bring you into this project.
Well, thank you. I'm going to hand the baton back to Xander, who has some more questions himself.
Hey, thank you, Kevin. That was really great. I mean, I think we don't have that much more here, but I think I would really love to kind of understand, what is the kind of economic loop that you have going with the product that you're creating now? Is it in kind of beta? Are you, and I realize that part of this is that you're raising some money around this project. So I want to make sure that we talk about where you are in that phase of building the economic model and also some of your fundraising efforts that are around this.
Right. So our model is based on that. There's a need in Madagascar for famine and malnutrition relief. There's international food agencies that import protein to Madagascar to feed the famine areas. And COVID has only made this worse in Madagascar right now. There's never been such a need, for example, in the south of Madagascar, for improving the nutrition, especially of children, where over 50% are malnourished. And I repeat this again, there cannot be hope in Madagascar unless you have kids in school that have eaten and they're learning and they're becoming the next solution themselves for the country. We need to invest in that. There's not a quick answer, but one of the answers is nutrition. So we want to actually sell our product to that international food relief agencies. We're doing it now. We created a need for it, but we're only meeting about 10% of that need right now. And we expect we can make that need expand to more and more food relief agencies in Madagascar and in Africa. So once we have finished expanding across Madagascar, we hope to also expand this idea, this model, into Africa. But to do that, step one is to actually produce our first large-scale farm that could feed about 55,000 children a year.
And how many, roughly, how many pounds of stuff is that?
Well, we can work it out that
product.
It's about 600 meals at 25 grams each that would be produced by this one farm. That's what's produced by this one farm of about 3,000 square meters. That's a research lab and that. And we, one option would be to take investments and become like the other cricket farmers around the world, for example. But we want to actually do something different where we actually are developing new species in Madagascar to solve solutions or solve problems in different areas of Madagascar. In the south of Madagascar, that's where the famine is, but that's where they also are eating this incredible land turtle there, the tortoise that's just beautiful. And what if we could actually use cricket farming to prevent them from eating that endangered tortoise there? That's a solution that requires a new species, not the species we have in the capital, but a species that can grow in the hot desert of the south of Madagascar. And that takes research. We want to be basically the innovators, the problem solvers. And then after this, we hope that we can actually include investors to help us expand to different areas. But this first large-scale farm and center, I think, has to be, in a sense, managed without that type of investment.
And is there a way for outside people to help you in these endeavors?
Yes, if they're interested in helping us through fundraising, they can donate toward the California Academy of Sciences, our local great San Francisco museum, which I think this project really highlights the role of museums now in combining their history of science with current problem solving. And our museum is leading the campaign to actually raise the funds for this new and only center that exists in the world, really dedicated to this type of research.
Cool. Well, thank you so much. We'll make sure that we share the correct links on the feeds, and I think this is clearly an important project that's changing the way that protein is both created and consumed around the world. And it's just really great to see you and to be out of the house once again and hanging out with real people. So thank you all who have joined us on the feed. And I hope that you enjoyed tonight's talk, and we can't wait to see you at the next one. Thank you very much.